Hi everyone, and welcome to part 2 of my CNC rotor build. In part 1 I made the base for this rotor. In this part I will cover the assembly of the gantry with the Y and the Z axis on it. Together with the X axis the assembly should look like this. Before I get started I will give a quick overview of all the parts. So these are the stepper motors together with the controllers. I ordered them from China. So it took about 3 weeks to get here, and the box is a bit has seen some better times. The other parts, this is the spindle together with the drag chain. The spindle is ordered from eBay in Germany. This is the controller for the spindle. This is the spindle mount. These are the sensors together with the mounts for the stepper motors. This is general stuff. This is general stuff for mounting the item profiles and other things. Nuts, bolts, those kind of things. These are the plates to assemble everything together. They are based on the CNCZONE.NL open source CNC router, and Case milled them for me. He forgot to make some holes, which I still have to do myself, but that shouldn't be a problem. And then this part is the gantry bridge itself, and then here under the table we still have these are the Hewen rails, ball screws, and the X-axis rail supports. These are the construction parts for the gantry or the Y-axis. But unfortunately there are no holes right here. Some of the pockets holes were not quite big enough for the screw heads. I used a newly ordered carbide end mill in my cordless drill to enlarge the holes a bit. Afterwards, I could assemble the side parts of the gantry. This was needed to mark where the holes should be drilled. I still measured and scribed the exact locations. To get the tapping started, I used the drill press to get a good alignment. And I continued the fast way. Now I finally could fit the gantry side supports together. These supports will rest on the X-axis carriages. I added some anti-seize paste. I don't really think it's necessary, but I like to get things apart easily. To connect the profiles to the aluminum parts, threads are added to the ends of the profiles. I decided to do them all at once, both of them for the x-axis and one for the y-axis. To mount the rails on the profiles, I needed to put a lot of T-nuts into the slots. Then they needed to be spaced properly to finally screw the rails in place. I used these nitrile gloves to prevent my hands from becoming greasy and to prevent corrosion of the rails. Now I can put the garages on the rails. These come packaged in some kind of oil and need to be cleaned before use. I cleaned the ball screw for the y-axis using a cloth and a cordless drill to turn it. This went a lot faster. The first time I tried to mount the ball screw nut, I did it the wrong way, and of course some of the balls came out. Luckily it didn't take me too long to find them and put them back in. If you ever use something like this, be careful and look up how to do it. This is a better way to do it, although turning the screw is easier. This ball screw needs to be on this screw, lead screw, and there is a grease nipple that is normally sitting on here in this way, but when it's on there it sticks out too much and it touches this rail, And also, after the ball screw is, everything is mounted, this plate sits on here and the ball screw is at the back, so it's really hard to get to the nipple anyway. So for this I need to make a small pipe going from here a little bit down and then all the way to the end of the plate, so that there's a nipple, a grease nipple here, that I can grease this. I used a part of a copper brake line to extend the grease nipple. This brake line is exactly 6 mm outer diameter and is easily bendable in the right shape. So I found this old tire valve which I can use. I can drill this out a bit. It's just above 5 mm. Can drill it out a bit so that this 6 mm pipe will fit in there, and then I will cut it off. And at the other side I can put in the nipple, drill up to 5 mm and tap 6 mm and put in the nipple, and I can brace on this side and then put this in there, that on there, and the nip like this, and put the nipple there. So that should be it. I messed up the first tire valve by tapping 6 times 1 mm thread, while the nipple is 6 times 0.75 mm. So I had to look for another valve and start over. I drilled a 5.3 mm all the way and a small part 6 mm to solder on the brake line tube. The piece of brake line is a bit too long here, and I had to make it shorter later on. I used Loctite to glue the brake line to the ball screw nut. So I fashioned myself a custom-made drill in which the tip is 5 mm. This part is 10 mm wide. It's more like 5.5, and this part is flat, not angled. So I'll use it to enlarge these holes, enlarge these pocket holes. So right now this screw cannot fit in there, and it should be more like So actually these holes look really nice. There is a certain order in which the Z-axis need to be assembled. I had to take a lot of things apart multiple times to get it right. Here the bolts to hold the spindle mount need to be inserted before the rails. I created a small jig and used the top of the aluminum profile as a reference for aligning the Y-axis rails. The rail is tightened one bolt at a time. After adjusting the rail, After the top rail is tightened, the Z-axis support plate is mounted to the carriages and is moved a few times left to right to help everything settle in the right position. Then the carriages for the bottom rail are tightened as well. The last part is aligning the bottom rail by moving the whole system and tightening screw by screw. This ensures that everything moves smooth and relaxed and ensures that the rail doesn't lock up. Here I had to shim up the pillow block. It was too low compared to the Z-axis ball nut, causing the screw to move at an angle and lock up. I also had to put the Y-axis pillow blocks on the inside of the sides. This was because the motor mounting block did not fit over the pillow block. To do this I had to cut out a small piece of the profile. For my Y and Z axis I need to install these sensors, these proximity sensors. They are inductive proximity sensors, so they react to metal, and the place where they detect is on this ball nut. I should drill a hole through this profile about 130 millimeters from, or 130 millimeters from this side. I used a handheld wood router to make a flat surface for the proximity sensors. Well, this is what a nearly completed gantry looks like. I hope to see you next time in part 3 of my CNC router build. Hit subscribe to be notified, and you can also leave comments down below. And as always, thank you for watching.